Power to the truth. This is Margo. This is Monday, January 14th, 2019, 4:05 p.m. Pacific Time, United States of America. Hope everyone is doing well today, getting back into their swing on the workday, workday things, schedule and all that. And today we're going to be looking at methane and carbon dioxide and earthquakes. So I'm going to start with some comments that have come in under my video from yesterday. We're going to start with carbon dioxide because apparently, okay, we'll scroll back down to these other comments. So I'm going to start with this comment from Freedom Fighter 2. Says, according to NOAA, January 12th, 2019 was their highest daily average CO2 level ever recorded in the atmosphere, 413.45 parts per million. They are projecting a high of 414 parts per million by May of this year, but it looks like we may go past that. And so there was some conversation, and John Doe said, how did you get on NOAA's side? It's closed down. And I said, John Doe, the IASI sounding product site is up and data is available here. And you can click on that link and go there, and you can get methane and carbon dioxide, a whole bunch of stuff. And then I asked if Freedom Fighter 2 could share where he saw the NOAA data, and he said he saw it at CO2 Earth on Twitter. And so here's the link to that. And so here's where it was. Here's their Twitter page. And let's go down to the tweet that came out on the 12th. And here's the tweet. It came out, actually this one is on January 13th. Here's the one from the 12th. Well, that was before the spike came in. Here it is on the 13th. It says, for the 12th, 413.45 parts per million CO2 in atmosphere on January 12th, 2019. Highest ever daily average reported from Mauna Loa. NOAA source data and graphic. And here's the link. Daily records tracked. And so here's the chart from the Mauna Loa Observatory in Hawaii, where they register CO2 and get the readings in from around the world. And we can see the spike here. These dots go way up, and so then there are more tweets after that, and then it says said the spike is unusual, and the preliminary data is subject to quality checks by NOAA scientists. Scripps UCSD has now posted its data for Mauna Loa's CO2 for January, stating that it's too variable. And says their baseline reading not available, data too variable from Scripps. So it's up in the air as to what people think about that, but they're thinking there was a spike and then it's back down, but it's still high. I mean, it's back down to around 412. It says no daily Mauna Loa CO2 reading from NOAA for January 13th. Hourly data is too variable. No NOAA graphic. Also note, see NOAA graphic. Also note the hourly variability, respecting the unusually high jump to 413.45 ppm reported January 14th, 2019. So it looks like they're trying to cover their butts. But then they have a chart up of weekly averages from last week, 410.67, week before last 409.60, and a year ago, well, 2017, well, that was 2 years ago, 407.85. So I don't know, and they said 410.67 parts per million CO2 in the first full week of 2018, up from 407.85 ppm 1 year ago. So I don't know if they meant 2019. They put 2019 up here, but then they say 2018, and it's just confusing to me. So I do know that Hawaii is still has their volcano erupting over there, and that carbon dioxide is one of the main greenhouse gases that's emitted when volcanoes erupt. So I wonder if they had a spike because of that, even though it's supposed to be the average, a daily average. I really don't know how that works out. And Hugh Jazzoli says the CO2 levels are getting insane. Even on the Arctic cam, it is almost completely orange. So let's just go over to cams, and I have cams pulled up, and this is carbon dioxide. I don't look at this very often because it looks pretty much the same to me all the time, but their data does lag a few days for carbon dioxide on cams, just like it does for methane. And they've got data for Thursday and Friday of this last week, the 10th and the 11th. So I've got the North Pole pulled up, and this is total column. And so to have an average, it means that you're going to have some areas that are higher than the average and some areas that are lower than the average. And so on this chart down here, this color is 410 parts per million, and then this kind of getting into the medium tan color is 414, and then this darker, this is 418, this would be 419, and then this dark brown, darkest brown, would be between 420 and 1,000 parts per million, which is what we're seeing over here in China and Asia. So I've got the movie started here, so let's run this movie. So we'll be able to see pretty much the northern hemisphere here, and so the data is from Friday, and then it goes into the forecast period. So what you can see is it is gathering around the Arctic, like Hugh was pointing out, and we have high emissions from China and from I think this is North Korea. Wait, this is North Korea and South Korea over here. This whole area is China and East Asia over here. They are high polluters. China is the most polluted country on the planet, and it's the most populated country and the most densely populated country. And wherever you have industrial civilization, you're going to have high carbon emissions, high methane emissions, high surface ozone levels, and things like that. And this gets into one of the other comments that was left too. But we can see also the United States on the eastern part is a little bit darker in the carbon emissions. I think simply because this eastern part of the United States is more densely populated. And so with more dense population, you have more cars. You also have coal burning. And one of the problems with these emissions is countries like China and India and some of the other countries in the eastern hemisphere or eastern part of the world, they still use a lot of coal, and coal is the highest emitter of methane for as far as methane is one of the byproducts of coal production and coal burning. And also then you've got CO2 and soot and everything in the atmosphere when coal is burned. So wherever you've got coal, especially the dirt, they call it dirty coal because there are coal burning practices that were put into place in the Western civilization that are cleaner. They burn the coal cleaner, and so there are fewer emissions of carbon dioxide and methane in the atmosphere when coal is burned. So that's one reason that you see higher methane and carbon dioxide over in the eastern part of the world than the western part of the world. So now this is total column. Now if you want to really start freaking out, you go to surface level, and the surface level for carbon dioxide, it's not that bad depending on, let's go to global. Also, where there are, now this is interesting. So this is surface level carbon dioxide for the globe. And notice the high levels in South America and across the mid part of Africa. And then you've got some over here in China and in India, and a little bit over here in the United States. But mainly it's where these rainforests are that have been dying, and where, because they give off carbon dioxide when the trees are not being fueled, when they're dying, when they're sick and dying, they're actually emitting carbon dioxide rather than making oxygen. And the rainforests are being cut down and burned to make agriculture land. So that's another reason whenever it's burning, it's emitting all that carbon dioxide. And the reason you see it go up over here and then up over there, it's because carbon dioxide is measured when it's in the daylight. It's not measured in the dark. And also it can't be measured where there's clouds. I did all this research at the beginning of when I started doing this back in April and May. And so if people want to get a good background on this stuff, go back to some of my first videos. My first one was on April 28th, and it was on methane. And you'll get a good fast overview on all this stuff. So there's carbon dioxide. Now that's at surface level, and then when you start going up in the atmosphere, you can see it start to gather and spread out. Now here it's not too bad at 850 HPA, and because we can see like there's green areas down here, and this kind of kind of yellow-green is 406. So that's about here. That's 406. And that's at 850. But then when you go up to 500, it collects carbon dioxide. This is where it starts really looking bad. Up in the northern hemisphere, it does collect in the atmosphere, and that's why the climate scientists are so upset about the carbon dioxide, because it holds on in the atmosphere for 100 years. It doesn't go away. And so if we could just keep adding more and more and more to the atmosphere, and here it is higher up in the atmosphere at 300 HPA, and then here it is at 50. Now at 50 HPA, look how dense it is around the middle part, mid latitudes. That's very disturbing. That's very high up in the atmosphere. That's at 50 HPA. And so, you know, if you just keep adding, and then here's total column. Here it's more, where it's more spread out through the column. But we can see that when you just keep adding and adding and adding, and it takes 100 years for it to go away, that, you know, it's just going to keep going higher. So that's all there is to it. So there's that. So I think we've covered carbon dioxide. Now I'm going to go back down to this comment that came in from Robert Hayes under my last video. It says, "Thanks again, Margo. I'm trying to understand why it seems China has consistently high methane levels and India during days too. And summer I thought somehow agriculture or rain and soil microbes might have been a possible source during sunlight times. I'll have to read more or maybe look into Paul Beckwith's 15-minute clips. I'm a bit mystified as to what mechanisms are responsible for this seemingly major methane source. Have a good week." Yeah, and you're not the first one to ask this, Robert. And, you know, I've addressed this over on Facebook when people have asked in different places, and I didn't know either. And so that's why I did my own research and, you know, found out that methane can come from a lot of different places. So my response was, "Hi, Robert Hayes. I understand your curiosity about the high methane levels over China and northern India. Methane comes from many sources, natural and man-made. It is a product of civilization, i.e. people. China and that's the man-made part. China and India are very densely populated. Also, China is the most polluted country on the planet. Thus, you'll see these high methane levels in these areas. This wiki page is a good overview of sources of methane." And then I gave the link. "And I also recommend you listen to my first methane video I did here where I go into the sources. Thanks for watching." And then here's the link to that video. But this wiki page, I refer people to this all the time because it gives a really good overview. It shows where we were a long time ago and how it's gone up exponentially, and where we were 800,000 BC and how it's just spiked recently. And then it goes into, you know, where it comes from, what, you know, how it's a greenhouse gas, the cycle of it, and really like how it interacts with where it comes from, like the plants, the trees, the swamps, the cow farts, and and poop and human feces too. I mean, so when you have a high population and, you know, they've got a sewage system, you know, there's going to be high methane coming out of the sewage. So, and dumps and things like that. And also, and so here's a list. Here's this list of 10 things. Comes from permafrost glaciers and ice cores, which we know about that. Wetlands, warm temperatures and moist environments are ideal. So when you have swamps, when you have like the peat, and like the areas up in Canada and Alaska and Siberia where they've got those the peat and the permafrost melting, you know, it's going to be coming up there. Then it comes from forest fires, mass burning of organic matter, rice paddies. I didn't know that rice paddies was a major source of methane, but it comes from animals of all kinds. From livestock and termites. It comes from plants. It comes from landfills, wastewater treatment facilities, hydroxyl radical, and chlorine radical. So, and then it goes into, you know, how much with, you know, the different sources each year and this and that. And so I think this is then all the details from like animals and plants and methane gas from clathrates. Now this has to do with the Arctic and you know, the clathrates that are under the Arctic Ocean that are stored down there in the seafloor that they're worrying about. Then it goes into permafrost and so on and so forth. So, you know, I just direct people over to this page. This will give you everything you need to know to really understand. Here's coal mining. And I also found this article. I did a little research today, and this was from some project from November 28th to June 12th, where they were trying to figure out how to lower methane emissions from coal mining. So but it gives a lot of good information about methane. And this was from Germany, from this company in Germany. And so it's got all the information, but it says methane is the main greenhouse gas related to coal production. And I didn't know that. It is produced from underground and surface mines and as a result of post-mining activities, including coal processing, storage, and transportation. Globally, coal mine methane, or CMM, accounts for 6% of the total methane emissions caused by human activities. With a greenhouse potential 21 times higher than that of carbon dioxide, CMM emissions were estimated to be in the range of 400 million metric tons of carbon dioxide equivalent in 2005, and so on. And so this is a really good, it's a 35-page PDF document that you can download and read. But they even talk about how old coal mining operations that have been abandoned, you know, I mean old mines, abandoned mines give off methane too, because it's from deep inside the earth. So, and it's not just from coal. I mean, it's from any kind of mining operations, and that's why the miners have to be so careful, and that's why they would send the canary down there. It was to, you know, if the canary didn't come back, it was because it died from the methane from deep inside the earth. So I'm sure that's a longer explanation than you were wanting, Robert Hayes, but there you go. So, Sensible Hair says, thank you, Margo. You're welcome, Sensible Hair. Thank you for being here. Freedom Fighter 2 says, you are right. There is a disconnect between reality and what the establishment is telling us, especially the amount of UV radiation we are being exposed to. I've also noticed high levels of ozone at the ground level on a cloudy day. Have no idea what's causing it. Well, Freedom Fighter 2, high levels of ozone at ground level has to do with pollution and sunlight interacting. So I did beginning videos on ozone and UV, and if you'll look in the description box under all my videos, I'd say if you have not seen any of my previous videos, there's some good ones to start with, and I've got ones for UV and ozone linked in there too. But thanks for your comment, Freedom Fighter 2. I appreciate it. And then Fawn Hyena says, I started following you yesterday. I like your videos and I like your work. I hope one day I can meet you. I have a lot of questions if you have time. Yeah, well, just watch my videos, and if you've got questions, just put them in here. And just watch my videos, and you know, I answer a lot of questions in those. So thank you for your comment, Fawn Hyena. And thank you for being here, and hope you get a lot out of these videos. So that's all I'm going to cover on the comments. Now I'm going to close this out. Now, one thing, well, let's look at methane. I've got methane pulled up, and I promised I was going to show you methane. Oh, sorry, I hit the microphone. I promised I was going to show methane every day whenever there was new data. So we do have new data in from Friday, January 11th. And we've got North Pole view. We've got surface level pulled up here. And I've already got the movie loaded up, so it should go faster. It's got to reload a little bit. So the first day is the data, and then it goes into the forecast period. So we can see that in the forecast period, they're still showing this very high level of methane to be released in the Arctic Sea next to Novaya Zemlya here. And we're seeing this wave of methane, this dark red coming up, and see is just kind of like hanging around up here by Novaya Zemlya, and that's disturbing. And there's no sea ice right there. I showed where the sea ice has come back somewhat. But it's struggling right around, the line is right around here. It's right around there. So it's still in, this is the new color ledger that they updated, that they released back on December 11th to make things not look as dire. But we can see that the yellow orange is 2060 parts per billion, and then this orangey color is 2080, the red orange is 2100, and then this dark brown, I call it black, is between 2160 to 10,000 parts per billion. It can be anywhere within that range. And we do see high levels that do end up over India, covering India and parts of the Indian Ocean and all of China, and up into North and South Korea over here. Here's North and South Korea, and up into parts of Russia there. So, but that's not the only place. I mean, we see it all around the world, and we can see it over here, especially from middle United States over, Midwest and over. Wherever you have more humid conditions, you're going to have more methane too. That's just goes along with it. And look at this area up in Canada that's like constantly black. I think that was an area where there were some forest fires last summer. So if we look at global, the global view, since we were talking about methane emitters, go back to the beginning here, we can see, I'll load this up. It may take a minute for it to load up. We can see that South America has high emissions because of the reasons we were talking about with the forest burning down, cutting and burning the forests. And see, Brazil has high methane emissions. Also down here in the Congo in Africa, and then, you know, right over here, China, Asia, and this India, and also over here in near Saudi Arabia, where you have oil production. You know, that's high methane emissions. Wherever you've got oil drilling, oil production, natural gas drilling and production, all of that, those are huge methane emitters. Pipelines, all of that, you're going to have leaks, huge methane emissions. So you just can't get away from it with the amount of people we've got on the planet. Now that movie's going, I'll just let you watch that for a minute. And I showed recently how New Zealand has high methane emissions, and you wouldn't think that with it being such a small area, and you know, it's the paradise that everybody wants to move to, but they have high methane emissions, and they've got a high hidden methane area under the coast, under the east coast of the Northern Island, that if that fault line goes, you know, that those methane stores are just going to blow up, I'm afraid. And I've been doing research and found that there are high methane stores under the east coast of the United States, right along here, down in the seafloor, and they're all over the place. I mean, they can't send out expeditions and explore every inch of the seafloor, but it's all over the place. Okay, so let's leave methane. I do want to show you one more thing before we go to our earthquake report. I've got NASA Worldview pulled up here. I'll back out so you can get your perspective. Here's Africa, northern part of Africa, and this is the Mediterranean. Here's Spain and France. And we've been looking at Italy and Sicily because of Mount Etna, because of this area here. And so when I've been looking over here, I've also been noticing all this evidence. See the ripples in the clouds? I've been showing that in some of my recent reports. This is evidence of the beaming. It can be HAARP, it can be other kinds of atmospheric beaming that's going on, and it's microwaves that they're using, and it's actually heating up the atmosphere. And so it has to be where clouds are for you to see the evidence of it. The clouds take the shape of the ripples of the beams, and it's my theory that this beaming can cause, or not I don't know cause, but can be connected with earthquakes. And look, it's just here's Sicily, and the whole little island is covered. And here's northern Africa, and then so this island here is all covered with beaming. And then when we see more clouds coming up here in Europe, and you just keep going up, and the further you go, the more ripples you see. Look, here they are coming all the way up, and it's covering everywhere. And look at, they're going all different directions. Look over here in the water between England and Ireland, and I mean, this whole area is just being dumped on. I don't know what to say. I mean, this is today. This is January 4th today from NASA Worldview. So for whatever reason, y'all are getting the crap beamed out of you today. And it causes all kinds of problems. Look at that. Look at how they're like woven together almost. They're crisscrossed, and I mean, those aren't normal clouds. Normal clouds don't look like that. They just don't. So go back to some of my recent videos where I talk about the beaming and the 5G and all of that. And I did one that showed a HAARP ring. And look at, you can see the chemtrails. Look at the spraying, evidence of the spraying going right across. See those straight lines? Right across. That's where you're being sprayed. You kind of have to, you know, really zoom in and start sorting some of this stuff out. But, you know, anybody can go and look at these things. And I always leave links below so that you can go and look for yourself. But that's a mess. And, you know, maybe that's keeping that snow over there, causing all the snow to be dumping over there. I don't know. It's not looking good. You're being beamed. The whole area. So, weather modification. It's all over the place. It's everywhere. I mean, if I dig deep enough, I can find it any day of the week here on NASA Worldview. Somewhere in the world, I can find evidence of beaming. So there you go for that. So, let's shut that down. Wait. Get my No, I'm not going to shut that down. I'm going to leave this up for my backdrop. And now we're going to go to earthquakes. And I want to just show you something real quick. I have EMSC earthquake reporting website, and when you click on, you can click on the tabs. They show Europe and Mediterranean earthquakes, and look at all the earthquakes here. Now these are ones that are not, don't show up on USGS for whatever reason. A lot of these are smaller, but look at all these earthquakes. So you think that they're not as a result of that beaming? I mean, the beaming can certainly take a part in it, can certainly have a part in causing earthquakes, because it's microwaves heat up water, and it doesn't stop with the atmosphere. It goes into the water, it goes into the earth, and my theory is it can heat up the magma too. So there you go. So okay, now it's 4:46 p.m. Pacific time as we're getting started into our report here. I have USGS all magnitudes for the last 24 hours pulled up, and we're showing 258 earthquakes worldwide. And the earthquake makers are back at work, as you can see. And so now we're going to start with the 2.5 magnitude and higher, and it's showing 36 on the map. So let's start with the ones that are going to fall off the map soonest. So let's start in Alaska, because that's what's going to fall off the map here in just a minute. First one was a 3.0 near Anchorage, then a 3.1 near Anchorage, 2.6 near Koktovik, Alaska. So what I'd like to do, since the Alaska quakes are going to fall off first, let's just do Alaska first, and then we'll go around go around the planet. And so what we're seeing, I'll do Alaska. I'll do Alaska and this one too. So what we've got here for 2.5 magnitude and higher is 15 earthquakes in this area, and Alaska has had a lot of earthquakes in the last 24 hours. We're starting with the 3.0. Now you can see the blue dot when I highlight it. Anchorage, 2.6, Koktovik, 3.7, down here in the Aleutian Islands. Here's a 3.3 near Sandpoint, so this was getting more active. Then there was a 4.6 down here off the coast of Kamchatka, Russia. Now we're up to 4.5 here in the Aleutian Islands. Then 4.2, Koktovik. 2.6, Big Lake. 4.4 down here in the Aleutian Islands again. 4.1, Koktovik, Alaska. 3.7, Big Lake. 3.1, Koktovik. 4.6, Adak, right down here, right on the coastline. That was today at 4:18 p.m., 85 kilometers deep. And that was the last one. Now I think they must have downgraded some of these, because I kept seeing 5.0s. So I think they must have downgraded them. So let's go, while we're on Alaska, let's go to our all magnitudes and see how many are in this area. All magnitudes 88 for all magnitudes, including these Aleutian Islands, not counting Russia. But this includes some down here in the Canadian territory, and it includes the larger ones and the smaller ones. So now the small ones are important because that can be indicators of where larger ones are going to be happening. It can also be breaking up the earth there and making it easier for the magma to come up. That's my thoughts. That's just my thoughts. So, because I've had dreams and visions of these small ones being really important. I've been shown these in dreams and visions, that we really need to be watching these small ones. So that's what's going on in Alaska. Now, let's go back to our 2.5 and higher, and let's go down here. Well, actually, let's just come around the Ring of Fire. There was a 5.1 on the mainland of Japan, kind of near Tokyo. We can see this blue dot. Tokyo is down here. It says it was 11 kilometers south-southeast of Oyama, Japan. This happened yesterday at 8:23 p.m. Pacific time. 51 kilometers deep. Now that could have been big enough to cause some damage. I don't know if it did or not. It looks like it's like right next to this road, this highway. So it might have caused some damage to the highway. And it looks like this town, Koga, is the closest one. So I don't know about that. What kind of after effects they had from that. Now, down here was a 4.7 in the Solomon Islands that was 119 kilometers deep. This happened yesterday at 6:23 p.m. Pacific time. Then there was this one in Indonesia, 4.6 near Bitung, Indonesia, 41 kilometers deep. This happened last night. Here we had one that just came in on the island of Sumatra. It was a 4.9, 32 kilometers east of Sibolga, Indonesia. It just now happened. 15 kilometers deep. Well, it happened almost an hour ago. It's just now coming up on the map. 4.9, that would be big enough to cause damage if it was in a populated area. So, but I would not imagine that to cause a tsunami because it's further inland. Okay, here's a 4.6 near Mingla, China, that happened at 2:54 this morning, 10 kilometers deep. Here's another one, a 4.6 near Arzak, China, that happened today at 5:49 this morning, 30 kilometers deep. Here's one in the Arabian Sea, right on this red line, A 4.7 that was 147 kilometers south of Oromara, Pakistan, 10 kilometers deep. This happened yesterday at 10:36 p.m. Pacific time. Then we've got one up here in Iran, a 4.3 that happened near Sarpol-e-Zahab, Iran. Happened at 10:18 this morning, 10 kilometers deep. Here's one in Italy. Looks like it happened right on the coastline, right near Ravenna, and it looks like right on, literally, like right next to the coastline. 4.5, 7 kilometers east of Ravenna, Italy, 10 kilometers deep, that came in at 3:03 this afternoon, Pacific time. That could have caused some damage, I don't know. So that's in that beaming area that we just saw. We saw it beaming all around this area and all the way up here. So I'm not surprised, frankly. I'm just not surprised. Now, let's go down to Mexico. We're showing a 4.3 on land, right near this road, and right near Niltepec. It says it was 5 kilometers south-southeast of Niltepec, Mexico, 4.3 magnitude, 82 kilometers deep. That came in at 2:35 p.m. Pacific time today. And there's more. I mean, that's not the only one. If you go back over to EMSC and you click on the world map, you can see all of these down here. And you can zoom into the different areas, and then they've got the whole list. Like northern Italy, they've had a 3.1, 4.8, 4.3, southern Italy. So this 4.8 came in an hour and 49 minutes ago. That was what we were just seeing over there. Then here's central Peru and this and that. I mean, they've got a whole list over here that USGS doesn't have, because USGS doesn't show a lot of the smaller ones internationally. So there's that. Now let's go to Dominican Republic, and let's go to all magnitudes for this. Well, let's go to Hawaii next, since I'm looking at the Pacific. Okay, it's spreading out, it looks like. Here is one in the ocean. We've got 13 total in the last 24 hours. This one happened at 2 o'clock this afternoon. It was a 2.3 near Hana, Hawaii, 13 kilometers deep. Then the rest were on the mainland. So I will just call these off and highlight them. 2.2, 1.8, 1.7, 2.0, 1.8, 1.8, 2.1, 1.8, 1.9, 2.2, 2.4, 2.3, and 2.2. So we're seeing more in the 2's range rather than in the 1's ranges there. So there's that. They're not big enough to cause damage per se, but they're it's still showing movement. Now the Dominican Republic is showing 13 in the last 24 hours. So we'll start down at the bottom, 3.0 near Puerto Rico, 2.5, 2.5, 2.2, 1.5, 2.5, 2.2, 2.2, 2.0, 3.1 San Antonio, Puerto Rico, 3.1 Isabela, Puerto Rico, 3.1 Punta Cana, Dominican Republic, and 3.3 just came in at Roadtown, British Virgin Islands. So we're seeing these are getting higher in magnitude. So they're mainly 2s and 3s now. So let's come on up to the United States. Nothing up in the northeast. Here we have a 2.7 near Maryville, Tennessee. That happened at 1 o'clock this morning, 13 kilometers deep. Here's one near San Antonio, Texas that just came in. A 2.5, it says it's 20 kilometers south-southeast of Nixon, Texas, 5 kilometers deep. It came in at 4:38 p.m. today. Here's a 3.6. Now this was downgraded because I saw this earlier today and it was like a 4.1, I think. I know that it was more than a 3.6. And it says it's near Waukomis, Oklahoma. It happened at 12:20 this morning Pacific time, 5 kilometers deep. So I cannot imagine that they would be out there drilling or fracking in the middle of the night. Even though that's, you know, that could have been the original cause of it, but, you know, they could have shaken something up and caused a fracture. So there's that. Now let's go up to the northwest. We've got an explosion. Here's our first explosion for today. Magnitude 2.1 near Princeton, Canada. It was minus 1.5 kilometers deep. It happened at 2:14 this afternoon. So it was up in a mountain with it being a negative depth. So the blasters are back. Next we've got a 2.0 near Silver Firs, Washington, 24 kilometers deep, and a 0.6, I'm not seeing, oh, right down here, a little tiny one, near Morton, Washington, 8.6 kilometers deep. Here's another one, west of Portland, Oregon. Here's another explosion, a 1.3 magnitude explosion, west of Vernonia, Oregon, minus 0.3 kilometers deep. So up in a hill or mountain again. We saw an explosion there last week too. I remember that name. So let's see what else we've got. Let's go over to the Yellowstone area now. Right up here is a little one, minus 0.1, so microquake near Polson, Montana. Here's a 1.5 near Lincoln, Montana. Here is 0.5 near Whitehall, Montana. 0.7. Oh, that's a minus 0.7. So that was a microquake near Whitehall, Montana. And a 0.6 near Three Forks, Montana, all in that same area. Here's a 0.8 near Lima, Montana, and a 1.3 near Challis, Idaho. So let's see how many are in that area. 8. So that number has picked up for today. So 8 in that area. I think that's all of those. Now we've got some activity down in Utah. We've got 4 down here in Utah. Here's a 1.5 near Enterprise and a 2.2 near Enterprise. And then right on the other side of the border to Arizona, there's a 1.6 and a 1.6 right beside each other. So those are all part of that hazard area. Now let's come up to Northern California. Here's a 2.6 near Rio Dell, California. Or it shows 2.7 down here, 2.6 up here. 27 kilometers deep. That happened this morning at 10:51 a.m. Now this is significant because remember we had one yesterday right here on this where these red lines were crossing. So this one is right next to that. So that's significant. Now we had 1.7 at Willows, California, and a 1.4 at Willows as well. Then there was a 1.5 near Quincy, and a 0.8 near Cold Springs, Nevada. This is getting into the Reno area. Let's see if there's anything else in Northern California. Let's get the geysers while we're here. 6 at the geysers. They're all 1.4 and under. So now let's go on over to the Reno area. Pyramid Lake had another one right in the lake. We've seen it right there before. 1.0. This happened at 3:18 today p.m. 16 kilometers deep. Where was the Cold Springs? Oh, they called it Cold Springs, but it's way over here. Oh, that's Quincy. Oh, here it is. It was small. It's northwest of Cold Springs, California. Okay, now we got one down here near, it's actually closer to Lake Tahoe than Carson City. It's up in the mountains to the east of Lake Tahoe. It was a 1.1 at 3:40 this morning, 10 kilometers deep. That's all in the Carson City area. See if there's anything else up in northern Nevada. I'm not seeing anything. Now we'll cover this area. Now we're getting towards the Hawthorne area. Here's a 1.2 at Gabbs. These are ones that we see all the time. Here are small ones that are just peppered around for whatever reason. Now I'm seeing a lot down here near Mammoth Lakes. So let's hop down here. Here's a 0.1 at Bridgeport and 1.1 at Bridgeport. Now let's go to Mammoth Lakes. Here's Mammoth Lakes and the Long Valley Caldera. So this is an area that we're going to be watching closely. We have 22 here today. So we're seeing a swarm. I would call it a swarm. And they're small. It's starting with a 0.2. See? 0.2 right here. And then they're going, here's a 1.7. Here's a minus 0.1. So there's some of them are microquakes of 1.3, some 1.0s, 1.1, 1.6 is the biggest one right here. But it's swarming near this Long Valley caldera. So that's showing movement of the magma, folks. And let's see what the depth is of these, if there's any that had a negative depth. I don't see a negative depth on any of those, which means that it's not coming up into the mountain at least. So that's a good thing. Now, so these are down in the Nevada testing area where they have underground nuclear testing and stuff. And there's 21 on this map, including Beatty, Pahrump, Alamo, and Goldfield, Nevada. So that's all down there. Those are small. Now let's come down here. We've got here's a 1.0 at Coso Junction and a 1.3 at Little Lake and a 0.5 at Little Lake. Now, oh, here's another one, a 0.8 near Baker. Let's get, okay, I got those. Let's check out this one in the San Francisco area. Here's a 1.7 northwest of Crockett, California. It happened at 12:22 p.m. today. So it's in that San Francisco area to the east of the bay. That's what you can see there. Now here's one at near San Jose, a 1.2 near Morgan Hill, 8.2 kilometers deep. Here we've got some lined up on the San Andreas fault line. 2.2 San Ardo, a 1.7 San Ardo, .4 Parkfield, 1.1 Parkfield, and a 1.4 Parkfield. So I'm always watching these that are lined up right on that San Andreas fault line. Here's one by itself, a 1.8 at Santa Ynez. And then coming down into Southern California, we've got one off the coast of San Diego again. Looks like right just barely in the water. 1.4 near La Jolla, 9.8 kilometers deep. Okay, let's see what we've got in Southern California. Got them all in the picture here. We got 45 here today. Here was a 2.1. I'm just going to highlight some of the bigger ones near Beaumont. Or if something just sticks out at me, I will highlight them. Most of them are under ones or in the one-ish range. I don't see any explosions yet down here. That's a good thing. Okay, so that 2.1 was the largest, and right down here is where we have the Kauai area. That was it. Oh, there's a 2.6. I missed that one. That was our largest. So there's that. So let's zoom out and see if anything else came in while we were doing the report. Looks like we had a new 4.7 come in near Somlaki, Indonesia. It just came in at 4:56 p.m. today, 167 kilometers deep. Let's check that out. So that was in the ocean, right next to this red line. So that didn't cause any damage, but again, it's movement, and it's a good size of 4.7. That's getting close to 5. Let's see what else. We've got some 3.3 that just came in at Roadtown, British Virgin Islands, 106 kilometers deep. We just had a 2.2 come in near Hanaunau, Napupu, Hawaii, minus 1.8 kilometers deep, so that was up in a mountain. It looks like we just had a 3.5 near Larsen Bay, Alaska, 79 kilometers deep. And we got that one at Nixon, Texas. That was down by San Antonio. We got that one. And then some more small ones are coming in up here in Alaska. So you can see that things are coming in fast. And, you know, as soon as I get done with a report, there's more stuff. But, so we need to be watching this Caribbean area, because we had a 3.3 that just came in at Roadtown, British Columbia, and that was at 4:58 p.m. And then they had another 3.3 at 4:40 p.m. So 18 minutes later. Same magnitude. And then the Dominican Republic, that whole area. So this is picking up down here. I expect to see this picking up. See, we got two recent ones. Those are those 2 recent ones that I was just showing you. So that's to be watched. Now, let's look over here real quick. Now, I think that's all I want to look at today. So I'm going to go ahead and wrap this up. I've been at this for an hour and 15 minutes because I went over a long explanation about methane and carbon dioxide and stuff. But sometimes you just have to do that. You know, we're in a classroom here, and we're all learning together, And as you have questions, do bring them up, because it might have been some area that I've researched or that someone else has researched and they already have the answer for you, or you can research it yourself and let us know what you find. So again, my message is that time is short. No one knows the day or the hour. I do believe we are in the end times, and we are seeing signs of these being the end times. And as a result, I recommend that everyone get their spiritual houses in order and be ready to exit planet Earth ASAP. So until next time, I love all of you. God bless you. Go in peace, and I'll talk to you soon. Goodbye.